video is on a system of linear equations and how we can find a solution to a system of linear equations. Now, we all know what a linear equation is. An equation with the form y equals mx plus b is a linear equation. Now, if I moved the x's to one side and wrote it this way, this is still a linear equation. Excuse me. It should be that. So a system of linear equations will involve two equations. Two linear equations, and it could either be consistent or inconsistent. Inconsistent would mean that the system would not have a solution. There is no solution. Consistent would imply that there is a unique solution for x and y. Now, what is the solution geometrically? Geometrically, since we have two lines, the solution is the point of intersection. Of the two lines. So when you find the solution, you're actually finding the point of intersection of the two lines. The solution is generally obtained by two steps, two simple steps. First step is elimination, and the second step is called substitution or back substitution. Here are a few examples. Here's my first example on solving a linear system. Let's say x plus 2y is equal to 5 and 2x minus 3y equals 4. Now, the first step would be elimination, which would mean I eliminate one of the two variables. That is a matter of choice. You may either eliminate x or you may eliminate y. I am going to eliminate x. I'm going to take the first equation and I'll multiply both sides by 2. That would give me 2x plus 4y equals 10 and 2x minus 3y equals 4. Now when I subtract the two, the x's would get cancelled. I have 7y equals 10 minus 4, which is 6. So y would be 6 over 7. Now that I've found the value of y, I perform the next step, which is back substitution, which would mean that I take the value of y and plug it in one of the two equations. I'm going to plug in the value of y that we found in the first equation. So we'll have x plus 12 over 7 equals 5. Move 12 over 7 to the other side. Have a common denominator by multiplying and dividing by 7. Now you have 35 minus 12 over 7. The answer is 23 over 7. So our solution is x is equal to 23 over 7 and y equals 6 over 7. You can actually verify if your solution is correct. Take the value of x and y and plug it in both equations. It must satisfy both equations. Let's plug in the first equation. I'm plugging in the values of x and y on the left hand side. which gives me 23 over 7 plus 12 over 7. I end up getting 35 over 7, which is 5, which is the right hand side. It checks out. Now you have to verify for the second equation also. So 2 times 23 over 7 minus 3 times 6 over 7 will equal to 46 over 7 minus 18 over 7, which is 28 over 7. You get 4, which is the right hand side that we had. So our solution is correct. Now what does this mean? Now what did we just find? As I mentioned earlier, this is nothing but the point of intersection of the two lines. Let's rewrite the two equations. The first equation would become minus 1/2 x plus 5 over 2. The second equation would become two over 3x minus 4 over 3. If we graph this, the first line is a decreasing line. It has an intercept at 2.5. Perhaps I could draw it like that. The second line has an intercept of negative 4 over 3. Perhaps it's over here, and it is increasing because the slope is 2/3. So I arbitrarily draw that line. So the solution we found is nothing but the point of intersection, that point, and that should equal to 23 over 7 on the x-axis and 6 over 7 on the y-axis. So by all means, when you find a solution to a linear system, you are finding the point of intersection of the system, of the two lines. And the system is consistent because we have a unique solution. Here's a second example. 3x minus 2y equals 24, x plus y equals 12. So the first step is elimination. I believe I can eliminate y in this problem. So I'm going to take the second equation and I will multiply it by 2 on both sides, which would give me 2x plus 2y equals 24. Now the first equation is 3x minus 2y equals 24. When I subtract them, when I add them directly, I have the y's getting cancelled. I have 5x is equal to 48, which should mean x is 48 over 5. The second step is back substitution. So I take the value that I just found and I plug it in one of the two equations. Again, it is a matter of choice, doesn't matter which equation you pick. I'm going to pick the second one because it seems quite easy to me. I have 48 over 5 plus y equals 12. Move 48 over 5 to the other side, so y would be equal to 12 minus 48 over 5. And multiply and divide by 5. I will get 60 over 5 minus 48 over 5, which would equal 60 minus 48 over 5, and you'd end up getting 12 over 5. So the value of y is 12 over 5. So our solution is x is equal to 48 over 5 and y is 12 over 5. That is the point of intersection of the two lines that are given to us. Again, the system here is consistent because we have a unique solution. Another example. Solve the system. Let's say you have 2x plus 5y equals 40 and 3x plus y equals 50. I have to choose one of the two variables to eliminate. So for the first step, I will choose second equation, and I multiply it by 5 on both sides. So the second equation would now become 15x plus 5y equals 1250. So, excuse me, it's not 1250, it's 250. Bad math there. Now I could take whatever I have and I will combine it with the first equation via subtraction. When I subtract, the 5y and the 5y would get cancelled. 15x minus 2x is 13x. 250 minus 40 is 210. So x would just be 210 over 13. Step 2 is substitution. So I take the value I found, I plug it in one of the two equations. So perhaps I'll plug it in the first one. I'd get 420 over 13 plus 5y equals 40. So 5y would be equal to 40 minus 420 over 13. I'd like to have a common denominator, so multiply and divide by 13. So 40 times 13 over 13 minus 420 over 13. 40 times 13 is 520 over 13 minus 420 over 13, which would just give us 100 over 13. So 5y is 100 over 13, divide by 5 on both sides, you'll get y is equal to 100 over 13 over 2, over 5. You flip and multiply, you'd end up getting 20 over 13. Therefore the solution here is 210 over 13 and y is 20 over 13. So suppose let's take this problem, x plus 2y equals 8 and 2x plus 4y equals 16. And the first step is elimination. And when I do elimination, I multiply the first equation by 2. I will get 2x plus 4y equals 16. This is the first equation. After multiplying it by 2 on both sides. But it looks exactly like the second equation. So when you subtract them, you get 0 equals 0. This is a true statement, always. So this just means that we end up having infinite solutions. And the system is inconsistent because you have infinite solutions. What does this mean geometrically? If you rewrite it, the first equation would be y equals minus x over 2 plus 4. The second equation is 4y is equal to 16 minus 2x. Divide by 4 on both sides, you'll get minus 1 over 2x plus 4. So pretty much, although at the beginning they kind of looked different, they are the same equation. So you just have one line superimposed onto itself. So you will have infinite solutions. So one line is being superimposed onto itself. By all means, you're just looking at the same line. So this is an inconsistent system. Let's take another example. Slightly different from this case. X plus y equals 12 and 5x plus y equals 24. Now you try to eliminate it. Well, when I eliminate it, I just subtract them directly because I don't have to do any sort of operation here. When I eliminate them, I get 0 equals negative 12. 0 cannot equal to negative 12. That is a false statement. So in this case, you have no solution at all, and the system is inconsistent. But geometrically, what does this mean? Well, if I move the 5x to the other side, I have minus 5x plus 12. And do the same thing for the second equation, I have minus 5x plus 24. So by all means, these are two decreasing lines, one at an intercept of 12 and the other at an intercept of 24, and they are parallel to each other. And we know two parallel lines do not have a point of intersection. So the lines are parallel, so which would imply no point of intersection. And that just implies no solution. So going back to where we started and making the system inconsistent. So this is how you solve a linear system. Of course, things get complicated when you go to bigger dimensions, when you have more variables. Keep in mind, if you want to solve for 2 variables, you need two equations. If you want to solve for 3 variables, you need 3 equations. If you want to solve for 4 variables, you need 4 equations, and so forth. So I hope you can practice more on linear systems and solving them. Thank you for watching the video.